everyone. In this video, we will discuss about the various pins required in data transfer and instruction execution of 8085 microprocessor. It is a 40 pin diagram. This is the 8085 pinout diagram. You can see that the first two pins are X1 and X2. These are called the crystal connection pins. The 8085 contains an oscillator on chip, which is on chip. This oscillator is connected between these two pins, X1 and X2. It provides the necessary signal to the peripheral and the processor. Here comes the third pin, which is reset out pin. When it contains the reset out signal. When the signal goes high, it goes to the peripheral and reset or initializes the whole system. After the reset out pin signal is high, the actual processing of the system starts. Here comes the next two pins, which are SOD and SID. SOD stands for serial output data, whereas SID stands for serial input data. These are used when the peripheral can process data in serial form. Example, accumulator. Um, uh, SID accept data in serial form, whereas SOD sends out data in serial form. Next are pins 6 to 11. These pins are the part of interrupt signals, namely trap, RST 7.5, 6.5, 5.5, INTR, INTA. The first four, that is 6 to 9, are the part of interrupt signals, whereas 10 and 11, INTR, INTA, are added to the system to expand the system. If two interrupts reach the processor at same time, then the processor will serve the interrupt which has the higher priority. Here trap has the higher priority. Next pins are from 12 to 28. These include the external data bus as well as the external address bus, namely AD0 to AD7, A8 to A15, except the pin 20, which is the voltage pin. The lower address pins, that is AD0 to AD7, is multiplexed with data here. Next are pin 29 to 34. These are called the status and the control pins, namely S0, S1, read, write, input output. The S0, S1 and input output function together. They are related to input output and memory. When the pin 34, that is input output, goes low, it means memory operation is going on. When it goes high, that means input output operation is going on. The read pin and the write pin, these indicate that read and write operations are going on. These two pins are active low. For this, to activate these pin, low pulse is given. These two pin can never go low simultaneously. Next pin is ready pin, pin number 35. Many peripherals are very slow and cannot operate at the speed of microprocessor. One way to up their speed is using ready signal. We can also say that using ready signal, the peripheral devices and the microprocessor are in handshaking position. Next two pins are 36 pin, that is reset in, 37 pin, that is clock out pin. Reset in pin. When this pin is low, the CPU resets actually initializes. The CPU actually resets its temporary register, program counter and all other clocks. Also, CPU remains in this state until this signal goes high. Next, clock out signal. Peripheral, it is derived from oscillator. Peripheral to send out clock signal, clock out pin is used. This clock out pin is a system clock in which each cycle is a T state. The next two pins are pin number 38 and 39. Pin number 39 hold and pin number 38 HLDA. The data transfer between input output and the peripheral involve microprocessor. This may slow down the speed of microprocessor. To avoid this, direct memory accessing, that is DMA process is used. DMA has two signals, hold and HLDA. Hold. In this pin, the DMA is requesting the processor to give up the control over the system bus, HLDA, whereas in this pin, The CPU microprocessor has acknowledged the hold request of the DMA and give up the control over the system bus for the DMA controller to take over the control and operate it according to itself. In this way, the CPU remains idle and data transfer between the input output and the memory is done without the interference of CPU. The last pin is VCC pin, which is the voltage pin. In this video, I have explained the 40 pins of microprocessor 8085. Thank you for watching.